Namaste, welcome back to Stitavragna channel, and you are watching AWS, the real-time cloud projects for beginner to expert level. And once again, we are almost close to becoming an expert. Okay, so I think what is the project number we will be doing in this video? 59, right? So let's assume we have almost got 2.5 year experience. Yes, this is all a real AWS engineer would do. Whatever we learned so far in 59 projects, right? Almost 60. We have 15 more to go. So you can proudly put in your resume saying you have almost 2 to 3 years experience. Yes, I mean, only do that if you have watched from the first video till here. All right, that being said, let's go ahead and do our 59th project, which will be securing a three-tiered architecture. So what do you mean by three-tier? Usually there will be multiple tiers in a project architecture. Three-tiered generally means a web server, then an application server, then a database server, right? That's how it is. So looks like we are going to learn how to secure that. So the founder of a local pet owners association wants to provide a way for pet owners to list their pets on the association website. The IT engineer needs to ensure that the system is secure because it will contain information about the owner and the pet. Okay, those trees look nice. So let's click on him. I don't know. We are floating in air as usual. So let's learn about the project. Hey, thanks for stopping. I am the IT admin for the Pet Owners Association, and I have an architecture security issue I hope you can help with. Hi there, I would be happy to help. What is your issue? We created a web application that city pet owners can use to register their pet name and owner info. I have the programming part done, but I am not sure how best to secure it. Okay, I can help with that. What does your current architecture look like? I built it in a basic three-tier design. A load balancer accepts the initial traffic. An auto-scaling group of EC2 instances then handles the web and app requests. Behind all of that, an Amazon RDS database runs Amazon Aurora, which stores the names and information. As I mentioned, web server, app server, then the database server. Great. It sounds like you are off to a fantastic start. Implementing security at all layers is a definite best practice within AWS. A traditional IT deployment would have only a firewall at the edge. But with AWS, you can use security groups and network access control lists to provide traffic control at every layer. That is exactly what I need to do. When I built the system, I couldn't get traffic to go where it needed to go. After investigating, I determined that security groups were blocking part of the traffic. Because I was not sure why they were blocking and I wanted to get things working, I simply opened the security groups up to allow all traffic through. Can you explain why the traffic was blocked originally? Sure. When a new security group is created, by default, it blocks all incoming network traffic, but allows all outgoing network traffic. At first glance, this might seem like it would keep the EC2 instance or other services that the security group is attached to from working. However, security groups are stateful, which means that they keep track of the network sessions established. By doing that, the security group can tell if incoming traffic is in response to an outgoing request. If it is a response, the security group lets it in while blocking all other inbound traffic that originated outside of the security group. That makes sense and it is kind of cool. Knowing that, how should I configure the security groups for the best protection? How should I? Okay, knowing that, how should I? Rather than open the security groups to all traffic, allow in only what is needed. For instance, because you are using Aurora with MySQL compatibility, you will have incoming database traffic on port 3306. You can configure the security group for the database to allow traffic only on that port. You can also restrict the traffic from only the sources you choose. In your case, that would be from the application servers. Great. You also mentioned network access control is what are those? We usually shorten the name to network ACL. or NACL, while security groups control network traffic to whatever resource they are attached to. Network ACLs control traffic in and out of an entire subnet. Also, while the rules that you can create in network ACLs are very similar to security groups, some major differences exist. Network ACLs are wide open by default, so they allow all traffic to enter and leave the subnet that they are associated with. Another difference is that they are not stateful like security groups. So if you use network ACLs to lock down your traffic, be sure to open both inbound and outbound ports so that the traffic can flow. Okay, that sounds more complicated. Should I use network ACLs? They might require a little more planning, but they add another level of layer of security if you want or need it. You have taught me a lot, but I'm not sure how I can implement it on my own. Can you help us tighten the security on our systems? Fantastic. Sure, why not? I mean, I appreciate the help. All right, so basically that's the overview of this project. And after watching this project, you will know how to review the concept of security at every layer, and then learn security group properties and how to use them. Then learn network ACLs and how to use them. This is a easy peasy lemon squeezy kind of thing for me. So let's click start. Here we are. Let's look at the video concepts. And as always, I highly recommend you to watch them. I'm not going to play them here, but there should be a playlist that will pop up here, which is AWS tutorials for beginners. Click on that link, go and search with these names. I have already uploaded these videos in that playlist. Go watch each of these videos if you have not already watched it. Then come back and watch the remaining project. If you don't watch this, then you won't understand how the service work in and out. So this is how you are going to gain 3 years of experience. If you skip this, then you don't know what each of the services has to offer. So I recommend it, and trust me, these are fun to watch. These are not theoretical. They actually show or explain with diagrams. I really like how they do it. So I recommend you to at least watch it once, and you can watch it multiple times if you want to know more about this, but at least watch it once. Okay, let's go to our diagram. So in this solution, security groups and NSCLs are used to provide a three-tier architecture with defense at each layer. So you have the application load balancer, but this is not one of them. Then you have EC2 auto scaling, then Aurora database. Okay, so you have web application and then sorry web server, application server, then the database. The three tiers in the solution architecture include application load balancer, an EC2 auto scaling group, and Aurora database. Security at each tier can be increased by customizing rules. In network ACLs, you can see network ACLs act at subnet level. So you can see a subnet, public subnet, private. Public subnet, why? Because the traffic, outside traffic has to enter. And if this is a private subnet, they cannot enter. So that's why usually this layer will be public facing, the remaining layers will be private. Okay, so and security groups so that only approved and appropriate network traffic is allowed to reach the resources. So subnet level, NACL, then the instance level, security group. Network ACLs control traffic in and out of entire subnet. Every subnet has its own network ACL, which can be customized. By default, network ACLs are set to allow all traffic in both directions. Network ACLs are also stateless. When you use them, you must account for all traffic both inbound and outbound. For example, you might block all traffic in both directions and then open inbound traffic on port 80 for a web application. If you do not also open the appropriate range of ports for outbound traffic, the web application's response will not reach the requester. You need to remember that. In contrast to network ACL, security groups control network traffic to a specific services network interface. By default, security groups block all inbound traffic and allow all outbound traffic. Security groups are stateful, so they allow response traffic to enter as long as the request originates from a service protected by that security group. Security groups control network traffic to the assigned service regardless of source, even if that source is in the same subnet. So that's about it. Let's go ahead and see our practice lab goals and DIY. Practice lab goals, we are going to examine existing architecture to ensure functionality. Then we will explore different methods of increasing security without breaking the system. Then we will update the NACL list for the database subnet, which is here. Then we'll update the application server security group to ensure that only traffic from the load balancer is allowed on port. So the securest way is you will only accept the traffic from application load balancer security group into this. And same thing goes here. And DIY, we are going to update the load balancer security group to restrict all inbound internet traffic to only port 80, which means on the security group we will open only on the port 80 and we will stop everything. Anyways, all inbound is already denied, so we'll only allow on port 80. Then we'll apply the load balancer security group to allow all inbound traffic from app server security group, which means this one. Okay, because when a user queries something, he has to return the data, right? So you access like this and then you return it like this. Okay, let's jump into it. This will be a fast one, and even the steps are not that many, and I don't think there will be any files to download. And as usual, don't forget to read the concept. I won't be reading it, so pause the video, read the concept, and move on. So we are going to go to EC2. Pretty much everything we will be doing there, and then scroll and then go to load balancers. And then click on the load balancer that is created, then scroll, then click or copy the DNS name. Okay, so when we click on it, it opens a web portal, and here you can see here is a list of pets registered in the city. And then go back to the security groups. Okay, and then we are going to select the security group of our load balancer security group, right? Which is that, choose it. And once you choose it, if you come to bottom, it will show you inbound rules. We can review it. So as you can see, all the traffic is opened on this, and all zeros, the cedar block means all zeros means from everywhere, all ports, everyone can access this one. And then we are going to go to auto scaling groups. Okay, and we only have one auto scaling group created. Then let's scroll down and review the subnet. You can see the subnet, it is leaving two subnets. Okay, and then we are going to go to the RDS. And in the RDS, go to the database clusters. There will be one cluster which will be already running. Okay, so it's a serverless Aurora MySQL. And copy the endpoint. Okay, let's go to the security groups. And then we have to choose which security group belong to the RDS, because RDS means what? Obviously, it is going to run on top of an EC2 behind the scenes, so it will have a security group associated with it. So, which is the database security group. Okay. Then we'll going to go to inbound rules and edit inbound rules. So why are we editing inbound rules? Because we are going to allow traffic from something else. So let's go ahead, click next. And if you see right now, again, even here, everything is allowed, which is what it is showing. Okay. But what we are going to do is we are going to change that to by clicking add a rule, Aurora, and then you will give a port if it is there. And then you will say allow only to which one. So who accesses RDS in this architecture? Obviously the application server. So we are going to only give access to the application server security group here, right here. Okay, so that's what we are going to see, and only on port 3306 because it's a MySQL database. What else you want to give access to other than this one? So once you give that, go ahead and delete the previous one because we don't need that, because this is kind of giving access to everywhere to everything, so we don't want to do that. Instead, This is the best practice. Only give access to. This is the principle of least privilege. We are giving access to only the things that require access, which is app server. Only app server accesses this. So why give access to everything? So we'll only restrict it to that one. Okay, read the concept. Okay, and then if we go back and click check host, then it will show, I guess, the database status page. Host name, paste it. So did we copy something? I think we copied the database endpoint. So I think we are going to paste it there. Then check status. Now it should show database is connected. Actually, I'm going to show you even before. Yeah, even before if you do it, it will say success because it is opened on everything everywhere. Okay, so we didn't break anything. That's what they are checking here. After modifying that, we didn't break any connections. It's still working, so we are good. Now we are going to click on the app server security group. Okay, and then we are going to go to inbound rules and then we are reviewing. App server already has inbound rule on 80 and they are giving access to this particular security group. I'm assuming this is coming from the load balancer and only on HTTP port. Okay, now we are going to go to the VPC. And in the VPC, we are going to go to the subnets. Then we are choosing the application subnet. Then copy the CIDR and repeat it for the subnet too. Okay. Okay. So why are we copying? Because when you are giving um, access to that, you can give it for a particular CIDR range as well. That is like restricting more of it. So how are we going to do? We are going to go to the network ACLs. In the network ACL, we are going to give access only to that particular CIDR, I guess. So let's go there. Choose this one, 6 subnets. I mean, why this one? I think we might have got that this. So which one to pick in this case? Let's see what they are saying here. Under click network ACLs in the network, choose the checkbox to select the first, or they are asking to select first. I think it doesn't matter. All defaults network ACLs should be listed. Okay. Then we'll review whatever is there. As you can see, everything is allowed. And this will get evaluated by the rule number, the lowest the rule number that will be evaluated first. In this case, this will be evaluated first. And then we'll click on outbound, and outbound same thing, everything is allowed. So by default network ACLs, everything will be allowed in both inbound and outbound. So we are going to create a new network ACL. And then we are going to pick lab VPC because that is the VPC that we are using for this particular lab. Then create network ACL. That's it. And once you have it, even if you don't give the name, that's fine. And right now, none of the subnets are associated with this NACL, as you can see here. So here, inbound, click. Again, we are going to edit it. Obviously, we are not going to um, allow any traffic. So we are going to click edit inbound roles. And then we are going to add a new role. And here we are going to say rule number 100 because as I mentioned, the lowest the rule number that will be evaluated first. Okay. So we are going to go with 100 and again MySQL because this subnet is for the MySQL. So when something comes inside, it will check only allow 3306. And then we are going to paste the CIDR block that we copied earlier. Okay, so not just on the port, we are also telling if it is coming from only this IP address ranges, allow it. Okay, so it's more secure. Even if it is coming from the security group of application server, it has to be within this IP address. Okay, then click add new rule, then save changes. Okay, did they say repeat the same thing or something? Okay, repeat the same thing for subnet to CIDR block. Okay, we'll do that. Okay, then we are going to configure outbound rules. and then click add new rule. 100 all traffic. Okay, outbound 100 all, and we are going to do this for both seeders, seeder 1 and again seeder 2. Okay, so we are done. Now we configure this NACL both inbound and outbound rules, but we don't have any subnets associated with it. So we are going to click edit subnets, and then we are going to associate our subnets that we are using for different layers, which are the database layers. For this one, it is just database because it only allows 3306. So obviously, we are going to only add or select the database subnets. We cannot select the application. For that, we can create two more NACLs, but I think they are already there. So let's see. And again, we are going back and checking the host to see we didn't break anything, right? And it is connected, so that indirectly telling us we didn't break anything after modifying this. So what did you guys understand? Okay, let me review or summarize whatever they are showing us. We will obviously do it again. So basically we have three tiers. We have load application load balancer, then we have auto scaling group, and then we have the database RDS tier. And um, initially we went and reviewed the load balancer, so security group and its inbound and outbound rules, and then we went and checked the auto scaling group and its subnets, and then we went to the RDS, and then we copied the endpoint, then we went to the database security group, and that was allowing all the traffic. So we said no, that is too much permission, so we added a new rule saying only allow on port 3306 from application server security group, and we added that. Then we went to the application server security group. Okay, and then we checked its inbound outbound rules. We did nothing. And then we went to the VPC and we copied both the seeders from the subnets. And then NACL, we went ahead and created an NACL where we created two inbound rules, two outbound rules. Both inbound rules allow traffic on port 3306 for the two seeder blocks. Same thing. Out we allowed all the traffic from the both seeder blocks. Okay, and then we edited the subnets of the NACL and added the database subnets. So pretty much that's what we do. So let's go ahead. I think when we do it hands-on, you will understand it more. Oh no, I closed everything. That is not good. Let me pause and come back. All right, it kicked me out of it. I had to re-log in and redo all of them. That's fine. Okay, so let's go to EC2. And in the EC2, if you go to the left side, you will have load balancers, and we have only one load balancer. Select that. Okay, and if you come here, and if you see I think we need to click on this, right? Copy that, paste it here. I think no, they didn't add any port. I guess that's fine. Okay, as you can see, here is a list of ports registered. If I check the host, it will work because remember, right? It is accessing all of it, so it's useless. There is no point in doing all that. Okay, so let's go up and security. You can see the security group here of the load balancer, and if you click on it, it is going to open the security groups which are in the EC2 itself. And if I select it, and if you see, it is allowing all. That is how it is because it's from outside, right? But that doesn't mean we have to open everything. We can restrict on a certain port because this is what HTTP, so we can just open it on port 80. We don't have to open on all ports. That is very bad. Okay, we'll take care of that later on, but right now let's go to our auto scaling groups, and let's click on this one. And if I scroll this a little bit up, okay, okay, this is our subnet. We have the subnet IDs right here, which are 98A and 1003. So, how do we open the subnets? We can click on that here. Let's see. We can enter from here. So, application subnet 1 and 2. What we can do is subnets are actually accessed from the VPC. And here application 1 subnet and application 2 subnet. This is the subnets for the application or the security groups, right? Sorry, scaling group, auto scaling group. And subnets usually we will just get the seeder blocks. If you remember, we copied the seeder blocks from the application server. We can do it right here, which is this one of them, and another one is this one. So let's get that as well. Okay, cool. So we got that, and then next thing on our to-do list is the RDS. Okay, okay, it went back. Okay, so you will have one database, which is this. Click on it, and then if I scroll down, let's copy the endpoint because we are going to use this endpoint here. So let's copy that, paste it here. Okay, so we have that endpoint. Now let's go to the database security group. So how can you do that? Can you go to the group here, subnet group? We are not talking about subnet group, but instead of we are talking about the security group of this. So obviously we are going to go back to here, security groups, and this is the security group of the database. And if you click on the inbound rules, and as you can see again, even this is allowing everything. So let's edit this, and we are going to tell don't allow everything, only allow MySQL. It's already there, MySQL Aurora. Again, it is going to go to the 3306, right? And here we are going to say like that's fine. Do we give it to everything? Obviously not. We are going to, who is going to access according to the architecture? Application server is going to access the database. So let's only give access to the application server security group, which is this one, app server security group of that one. That's it. Save rules. Actually, let's delete this one because we don't need that. Save rules. Okay, once we do that, we need to check if the connection to the host is still valid, right? So let's click on this one. And the changes to the security groups network ACLs are immediate. Let's copy and let's paste it here. Check status. Database is connected, so nothing broke it. If you don't trust me, I can go ahead here. And if you think, oh, whatever you do, it is going to work, etc. So I can delete this, save rules. It let me delete it. That's funny. As you can see, database is not connected because there is no security group role that is attached with it. So let's go ahead, add it before we forget to do it. Add role, MySQL Aurora, and not everything, only the security group of the application server. Save roles, and you can see how immediate it is, right? Oops. Sorry, I think we didn't give the database name previously. Oh, maybe that's why it's not. It's okay, that's fine. I don't want to repeat that again, but yeah, you will. You will not be able to connect anyways. Okay, so that's taken care of, and then let's go to the. We already went to the application server security group. Did we go to the application server security groups? I don't know. Let's go ahead and check that, which is this one. Okay, Inbound, again, it is only allowing on 80, which is good. And only to what? The load balancer security group, which is already created. That is nice. We don't have to edit anything. This is already properly assigned. Now let's go to the VPC. Don't we have the VPC? Okay, that's fine. Okay, we have it here. So let's go to the VPC and subnets. We already copied the CIDR blocks. So now let's go to NACLs. Okay, so these are the default ones. If I click on them, you can see the inbound rules all allowed, outbound all allowed. Okay, so let's not go there. So instead, let's create our own and let's name this NACL load balancer. It doesn't matter. I mean, you can give whatever you want. Sorry, this is for the database. NACL DB and the VPC we are going to use lab VPC. Let's create it. Even if you don't name it, that's fine. It doesn't matter. Let's click on inbound rules, edit, and we are going to add a rule which 100, and obviously this is going to be MySQL Aurora. And is are we allowing everything? No, we already copied a CIDR block. Okay, so let's copy and paste it and allow save changes. And we can actually, I should have added it right there, but that's fine. Add another rule. Okay, then outbound rules, edit, repeat the same process. But here we are going to give type all traffic, and then we are going to enter the CIDR blocks destination. Then let's give that all traffic and then the other CIDR block. Okay, so now it should evaluate only these two. All right, so once we finish doing that, let's go ahead and check again here. I don't know why it is removing that every time we are away. Check status and it still connects. Okay, so we didn't break anything. So that is good news. Uh, Anyways, I mean, we didn't because we didn't add the subnets yet. Also, obviously, it is going to work. We didn't break it. So let's click subnet association, edit subnets because uh, this one doesn't have any subsets associated with it. So let's go ahead and associate the database subnets, right? Both of them. Save changes. Now it has two subnets associated with it. Let's go ahead, put that here, check status, and it's still getting connected, which means we didn't break anything. So pretty much that's all they asked us to do as part of the practice lab. So let's go ahead and see what they want us to do as part of the DIY. Update the load balancer security group to restrict all inbound traffic to only port 80. Didn't they already do that? So let's go ahead. I don't know why I exited from that. Okay, let's go ahead and click on that person. Okay, when it comes back, that's fine. Let's go security groups and load balancer inbound. Okay, they are allowing everything. So now instead of that, they want us to allow only on 80. So 80 is, I think, HTTP if I'm not right. Yeah, 80. And this is 00 because delete this because this is the uh, entry point into our the application, right? So everybody from outside, so we have to give that 00. So let's save this. Let's go click on this person again to that. And what is the second thing they are asking us to do? Okay, update the load balancer security group to allow all inbound traffic from app server, all inbound internet traffic on 80 to allow inbound traffic from app. Okay, we can do that, but but which port? It is not saying which port, so that's fine. Let's go ahead and let's load balancer again. Inbound rules, edit it. They also want us to add another one. So I'm assuming it is HTTP but only for the application server, which is, yeah, but it doesn't make any sense. When you already opened up for everybody, why does it matter to give this to this one? That's weird. Oh, to restrict all inbound internet traffic to only, oh, we did that. But this is, I'm assuming, all ports, I'm assuming. So let's change that to all ports. It's not telling only 80. So why take the risk? Didn't we save it? Oh, this is app server, never mind. Load balancer. And we restricted to 80 for that one. So this wouldn't make any sense. So let me say all traffic. Oops, not this one. See, I almost did that mistake. So we should be careful. It's for the security group. I want to do all traffic. Save. I think pretty much that's it. They want load balancer security group ID, which is this one, and app server security group ID, which is this one. So let's validate. I think it will be green. What do you guys think? Leave it in the comments. Do you trust me? Yes. You did it. You tightened security controlling network access to the load balancer. Now return to the so it's, I mean, it's not tightening. By default, when you are setting it up, that's how you should do. You should never allow all the traffic to all of it. If you're a developer, you would never do that. Actually, there will be a separate security team who will be taking care of that. But anyways, I like this. Now you know what to do if you want to give least principle of least privilege. You know what is principle of least privilege and how to implement it uh, on security groups and network ACLs and etc. So let's click exit. Let's go back to this person and give him the good news. And if let me know what you think about this project in the comments. Thank you. We can now roll out the new website. The pet owners are going to love being able to share their pet names with each other. For your help, choose a reward. I think I like this one. It has water. And it's fireworks time. Yay. All right. And also feedback time. Go ahead. Uh, Not minimize, but exit from the full screen and hit on the like and leave a comment over there. Yes, I demand a comment. Nothing like that, but I would appreciate it if you leave a comment telling me whether you like the project or not. That way I would know in future once I finish this series to do more on this or not. Because if nobody comments, if nobody says they like it or they don't like it, then what is the point of me doing all this, right? So that is the only way you guys can tell me. Hit the like button. It just takes a couple of seconds, and also comment. Commenting let tells me that you guys want more of these things, and also it will help this video reach more audience. So that is in your hands, only in your hands. It's not in my hands. In my hands, I will make these videos, upload them, but I cannot make it reach to many people. That is in your hands. Okay. So thank you for doing all that. Now let's go and zap some drones. Okay. Hold on. Where are you running? Are these mushrooms? What is the purpose of numbering the rules for an NACL? Well, it evaluates the rules in order based on the number associated with each rule. Yep, that's what it is. I think it fell on us. Yep. Multiple security groups can be associated with a resource. Which rules are used to determine whether to allow access? The most restrictive rule wins. Only one security group can be associated. The rules from all attached security groups are aggregated to form a. The security groups are queried in the order that they were attached. No, I think the most restrictive rule wins, I guess. Nope. Nope. No. What does a newly created security group do by default with network traffic? What does it do? It blocks all inbound and outbound traffic. Seriously? Oh yeah, it only blocks inbound. It allows all outbound. You escaped. You escaped from me. Overconfidence. That's what is called overconfidence. What is the default setting for how network access control is handled traffic? Okay. It allows all traffic both inbound outbound. Yes. If an EC2 instance sends a request, the response traffic for the request is allowed to reach the instance regardless of the inbound security group. Why is the response allowed? Because security groups are stateful, are intelligent. It's funny. I see you. Okay, both are orange. I don't want you. Okay, here we go. Glue crawler can crawl multiple data stores in a single run. Let me go back. Think. Crawler when you run multiple? I don't think so. In a single run, I don't know. Oh, yeah, it can. I think I answered this question a while ago. Okay, looks like we are out of questions for. Oh, come on, you just skipped from me. Okay, let's do an orange one and let's call it a day after this. It's going to be IAM. I think we have plenty of IAM cards. I don't think we have to worry about it. Okay, so we have the cards. And what is it about? Users need to delete S3 objects, but they must do it through a special EC2 instance that has the permissions to delete the objects. The IAM users only have permission to log into the instance through EC2 instance connect. Okay, users, they have to connect to EC2 instance first of all. So let's put it there. Oops, nope, that's not here. I guess here. Here that should be the IAM. I think that's it. Yep, that's it. That's it. Okay, so that's about it, guys and girls. Thank you for all your support, subscriptions, memberships if you joined, and likes and comments. I hope to see you in future videos. Thank you very much. Have a nice day. See you in the next video. Peace out.